The howl of a dire wolf hasn't been heard on planet Earth for more than 10,000 years.
13,000 years after the last dire wolf walked the Earth, scientists say they've now brought them back.
Ben, I have to say, you pulled off what I think is the scientific miracle of the decade. What's your roadmap here, pal?
So we're working on the Mammoth, we're working on the Tasmanian tiger, we're working on the Dodo. I think we could save every species on the planet.
Save every species on the planet. That's pretty extraordinary.
All right, so De-Extinction 101, and remember, I'm not a scientist. I'm really curious, and I feel like I like to ask questions. I don't know anything about it, so I can ask, childlike questions about it, and then I get these answers.
One of the spin-outs I can't wait for you to talk about is the idea of artificial wombs.
I think that if we continue on the current course and speed, by the end of 2026, we will have the world's first mammal birth fully ex utero.
This provides a bridge to future developments like this that will break open all sorts of potential. What's the next species that we can look forward to?
Now that's a moonshot, ladies and gentlemen.
Everybody, welcome to Moonshots. I'm here with two incredible entrepreneurs and two dear friends. Salim Ismail, the head of Exponential Organizations, who you all know and love, and Ben Lamm, the founder, CEO of Colossal Biosciences. Colossal has been all over the news around the world. One of the top stories in April, the cover of Time magazine. And Ben, I have to say, you pulled off what I think is the scientific miracle of the decade. Seeing Elon capture the super heavy booster on Starship was sort of the technological miracle, but bringing back the dire wolf. And so what I put out a blog yesterday because I was really pissed off about this, this incredible achievement of bringing back to the planet Earth after over 10,000 years of extinction, 3 dire wolf pups. And a lot of people said amazing, but there were way too many people saying, is this real? Is this crazy? What is this guy doing? And to those haters out there, listen to this episode because I think this is an extraordinary achievement that heralds a future of synthetic biology that's going to blow our minds as much as AI is blowing our minds today. So Ben, how are you feeling about this? What was all this controversy about?
Well, I feel great. I've got weird, tough skin, right? I think that if anyone thought they were going to go into the de-extinction world, which involves, conservation, synthetic biology, AI, there's actually about 31 different ways to classify an animal. So you're dabbling into an area where a lot of people have a lot of opinions on a lot of different topics. So I think that it would have been really naive, to think that you're going to go into something like this and not have a lot of skepticism and a lot of negative feedback from the start. And then it's only going to get worse as you're successful, right? It doesn't go the other way. And so we've talked about this for a long time is like, what happens when we actually start to show the world animals? How does that feel? But I feel fantastic. The team feels fantastic. I think and I'll talk about the controversy, the only thing that I think is a little sad in my mind, I think you nailed it in your blog post, is that people miss the science. People miss the fact, I'm sure we'll go into it today, but it's like, I'm not a scientist, so it doesn't affect me. Like I sleep fine at night, but we have these incredible women and men that have spent the last 18 months, 7 days a week, passionately in love with bringing back the dire wolf. And whether you want to classify it as a dire wolf or Colossal's dire wolf or a genetically modified gray wolf, whatever you want to do, which we'll get into that conversation at some point, that doesn't matter. The fact that they took 72,000-year-old DNA from a skull and 13,000-year-old DNA from a tooth, mapped it and built a nearly complete dire wolf genome, which before this, there was only 0.15% coverage, right, of the genome, to go to nearly complete genome and to then select the genes that drove the core phenotypes of a dire wolf, engineer it into a gray wolf cell, which for many who don't know this, it is the closest living relative. It's not the closest relative. It's the closest living relative on the planet, which is a non-model species, by the way. No one's ever done this. And then to clone that, where you have a healthy birth of animals that exude phenotypes or physical attributes that are driven by genes that have been lost for 12,000 years, it's magic. And I feel
it's a miracle.
It's a miracle. And people just like, and not to mention just the genome engineering, right? So on our mouse, we announced the woolly mouse a month ago, and we had 8 edits in 7 genes. And we did it all at once using multiplex editing, meaning we did it all at once, 100% delivery, 100% efficiency, 0 off-target effects. That's a miracle. And yet we did get feedback on that. There's like, people have made 8 edits before, but yeah, they made them sequentially over 8 generations. And so to go from 8 edits to 20 edits, now using 15 of those edits being ancient DNA variants, it's awesome. And so the only thing that I was sad about is I don't really care what people call it, right? I'm not asking people to go to our website or watch our videos. I don't really care. But I think it's sad for the scientists that at a minimum, I think people could have elevated the incredible work by the women and men at Colossal and our academic contributors to the project.
Yeah. Salim, what question comes and pops out at you? I mean, you saw the press going back and forth.
I did, and I read your blog post, but I thought that was phenomenally detailed. I've been tracking this for a while. We first talked about this at Singularity University, and the way we used to frame it was, and this is going back 10, 12 years ago, was we essentially can now navigate conservation in a completely different way, in a totally different mindset. And there's some magic that comes from that. So I've got 100 questions, including as a company, your business model. My biggest question though is how? Because a lot of people have tried this in the past, and I'd love for you to give our viewers a sense of how you went about this, because this provides a bridge to future developments like this that will break open all sorts of potential. And I'd love for you to give some sense of the methodology used.
Let me inject one thing here, which is really important, that this idea of de-extinction is not just 4 years old, right? So Ben, you co-founded with George Church, who's the scientific genius at Harvard Medical School, a dear friend of both of ours, I dare say a very, very close friend of yours at this point. But he's been dreaming about it for many years, and it's been discussed for decades, and it hasn't happened. It's just now, in the last 4 years, that the tech exists. But I would say there's another thing that exists right now, and for those moonshot entrepreneurs out there, I want you to hear this. It's the difference that a CEO can make. The difference that a moonshot CEO can make in taking something from theory and making it real. And Ben, of course, you got multiple PhDs in biology and CRISPR and gene editing, right? I mean, your background.
I have no background in biology whatsoever.
I know that's the key point. No background in biology, but just a passion. So, if you could, let's bridge this into 2 parts. Number one, what attributes do you have that enabled you to do this? And number 2, what was the tech that enabled this, the dire wolf to come back and will enable a multitude of other species? We'll talk about those. Everybody, I hope you're enjoying this episode. Earlier this year, I was joined on stage at the 2025 Abundance Summit by a rockstar group of entrepreneurs, CEOs, investors, focused on the vision and future for AGI, humanoid robotics, longevity, blockchain, basically the next trillion-dollar opportunities. If you weren't at the Abundance Summit, it's not too late. You can watch the entire Abundance Summit online by going to exponentialmastery.com. That's exponentialmastery.com.
So fundamentally, I think that there's 2 things that if you're going to pursue a moonshotty approach to a project, there's 2 things that you have to remember. One is entrepreneurship. It's a team sport. Like it is. It is a team sport. Everyone's got to play their role. Everyone's got to play it well. A lot of times, 1 or 2 people get the glory or the negativity. But it is a team sport, right? Like you mentioned, I don't have a background in biology, so I have to trust our science teams to be able to do what they do, and I just have to empower them. And then the second thing is, I think you have to be a little more persistent than time. And I think you have to think about things in just knowing that, like, whether you have a great day or a bad day, everyone talks about, like, the trough of disillusionment and all these things. I think those things fundamentally don't matter. I think that if you're doing a moonshot, you just have to be looking. Like, I think about Colossal 50 years from now. I don't think about the direwolf launch. Like, people were like, oh my gosh, just to go through a little bit of PTSD, because I think it's important. I don't think anybody knows this. I've yet to say this, but let me, and then we'll get into the science that Salim asked, but I do think this is important. Day one, on Monday of last week, and I think you could make like a fun, like 24-hour or like a 5-day story that about this and just what happened last week. So we were not supposed to launch until Tuesday. We launched on Monday because we went to because the science is so detailed. And if you just look at a press release without like the scientific papers, without all of the data, without sitting down with the scientists, you could just say, oh, it's not a direwolf, right? Like I could easily have people get to that conclusion very easily. But I think that what we did, which I thought was smart, was we went and spent hundreds of hours with Time Magazine and with the New Yorker and with Rolling Stone and with a couple of key outlets and brought them completely unfold. We actually moved the wolves to a secure location and let them see the wolves, because we live in an AI generated world. Like, who's not to say someone couldn't just generate something, right? Like, not that we would ever do that. But I mean, that's the level that we put into that. We're certified by American Humane Society. We, flew the wolves on private jets. We literally brought in American Humane Society. We had 15 personnel with them at all times. We waited till they got acclimated to this new location. So we spent a lot of time and thought into this, right? Well, then we're supposed to launch on Tuesday. And so on Monday, we had all these people that have covered us over the years. We were going to give them the heads up. We actually had a scientific paper, and we had 9 handouts and an 11-page press release. So we had a lot of material. We were going to give it to all these people under embargo, so they didn't feel left out, even though we went really deep with these other people. And we said, we think this is a story that's going to persist. So we did that. Monday morning, I'm getting in the shower, kiss my 9-month-old son, say, oh, I'm going to go get ready for work, kiss him goodbye, about to get in the shower, looked at my phone, it's the cover of the New Yorker. New Yorker broke the embargo. So that happened, and our website's not live. The hundreds of press people that we worked with for years that have covered us pretty favorably when we didn't even have animals, feel betrayed. People are like, Time Magazine's calling, being like, you're on the cover of Time. Like, what did you do? Did you do this? Insane.
Wow.
So I'm in my car, speeding to one of our labs as fast as possible. And it's like, website's going live. People on Twitter are like, there's Laurel Mipsum on the website. And we're like, no shit. The website wasn't supposed to be live. And it's like, we had about 2 hours of content for YouTube that explains all the making of. We were going to roll out. We were just like, push everything live. So that was Monday. And then all those stories that we talked about came out, and they're all super positive, but no one got to digest the scientific paper. Didn't get submitted to bioRxiv. There was just all this stuff. So then Tuesday was, wait, oh, by the way, Monday, we're going to talk to all our scientific advisors, give them an update on the project, because we're worried that it could leak because it was just so cool. Our scientific advisors start calling us, being like, why didn't you tell us about that? Like, it was an insane ripple effect.
Best laid plans.
No, it didn't. Wait. Let me just give you. I know, like, I know we have a limited time, but you have to know how crazy it was. Yeah. Then on Tuesday,
they broke the embargo. That's really, really, really.
It gets way worse. It gets way worse.
Yeah.
Then, so I called up Revive and Restore, who's an incredible nonprofit. I love Ryan and I love Stuart. They actually, to your point, Peter, have been talking about de-extinction for a long time, but they're a nonprofit, right? It's like, this takes hundreds of millions of dollars in systems theory modeling to actually achieve this, right? You can't just do it with a nonprofit. And so I said, hey, just so you know, I was going to call you today to tell you about what's coming tomorrow, but this just happened, and I will tell you, we did meet with the Department of Interior, and they're excited about classifying de-extinction as a form of conservation. And the feedback was overwhelming. They're like, we've been trying to do this for 10 years. Oh my gosh, this is huge. That's Monday. Well, then Tuesday, we get this academic backlash, which is, no one cares about two things: the science which blew my mind. And as I mentioned, I thought it was a travesty. And no one cared about the fact that while we made 3 dire wolves, and yes, they're dire wolves, there were 4 red wolves that we cloned using a new non-invasive cloning technique, which I'm sure we'll talk about with you, Salim, in a second. But we developed a new technique to clone that's less invasive for animals. We made 4 red wolves, which are the most critically endangered wolves on the planet. There's only 15 left in the wild.
Wow.
No one covered that either, right? And then it became a philosophical and semantic debate on what makes a species. But what's interesting is there's about 30, I thought there's 11, there's about 31 ways to classify a species in all these different ways, right? And so by many ways, a polar bear and a brown bear are considered the same species, but they have a different species name and they look completely different phylogenetically. So there's all these different reasons or different ways to do this. And so that became the discussion. So then we're like fighting fire and just kind of like not really trying to explain ourselves, but just saying like educating people, like not trying to persuade, but just educating, like there's actually a lot of ways to do all this. So that was Tuesday. And then Wednesday, and then by the way, the conservation community is super stoked about, at least new tools in conservation. So I was like, okay, well, it's a win, whatever. So then Wednesday, there's a cabinet meeting, which obviously we're not a part of the presidential cabinet.
Like the U.S. cabinet.
U.S. cabinet. There's a cabinet meeting, and we have not talked back to the Department of Interior, so we don't know the full context of the meting, right? Because we're not in the cabinet meetings, we're not part of the cabinet of the United States. And a comment was made about de-extinction, and the Department of Interior and Secretary Burgum is very passionate. He told us in the meeting with us that he's excited about getting animals off the endangered species list. But that's not removing them, that's recovering them. That means that we have enough of them that's healthy enough that they're no longer on the, and he made a comment that we put things on the endangered species list, but they never come off. And so how do we get animals off using technology? And so we thought, but once again, we live in a moderately polarizing climate right now. And so that became, and I don't know if I can't speak for the administration, but that became de-extinction is now being used to get rid of endangered species. Like, wait, what? So that was my win. So that was my Wednesday. And then Thursday, I was like, we'll just answer whatever questions come up, right? And so last week was a little bit of a crazy thing, but going back to your original question, at the end of the day, like that was 1 week in time, and Colossal is looking at 50 years. And our goal with Colossal is to bring back these species as well as use all those technologies to save existing species. And so in that model, you have to think on a 50-year horizon. So if you get great press on day 1, which we did, and you get crazy press on day 2, that's okay. Those are 2 days in a 50-year journey. And I think you have to think like that.
So let's talk about, I have so many questions, buddy. And I'm so proud of you. And just for full disclosure, I'm a seed investor and advisor to Colossal Biosciences. I've met Ben, and there's something about you as a CEO that you've got the right phenotypic attributes that people just want to support you. And what you've done, I mean, how old is Colossal these days?
So we were founded in September 2021. So
okay, so you're 4 years old, and
yeah.
You went from a $0 valuation at a first conversation with George Church to now what's your valuation today?
Our current valuation is 10.2 billion.
10.2 billion. That's pretty insane in 4 years.
Yeah.
I want to talk about the business model, but the science, real quick. Sort of de-extinction 101.
All right, so de-extinction 101. And remember, I'm not a scientist, but you basically so far.
Wait, can I just pause for a second?
Oh yeah, go for it.
I think this is so important when people think about moonshots, etc. You have no background in biology to be doing this, right? Just as right. Elon has no background in space or the car industry or the energy industry. It's people coming in with a beginner's mind and an MTP, leveraging new technologies that are accelerating naturally, and that formula gives you any possibility in the world. And I think that's such a huge thing that we should drill down on. But anyway, back to the science I want to highlight. I think it's so great.
I'm really curious, and I feel like I like to ask questions, and and George will sometimes say that I'm the best student he's never had, because I like to ask weird questions, and he's like, I didn't think of it like that. And those aren't like scientific breakthroughs. They're just, to your point, I don't know anything about it. So I can ask, childlike questions about it, and then I get these answers. And, it's great.
Okay, on to the science.
Okay, so the science, one of the reasons why we've had to raise so much capital is you have to build the entire system, right? So just like going to space or even just building a software system, the whole system has to work. You can't just design the software. You got to build the software. You got to build the hosting. You got to build all the API calls. So you have to think about it. So I think, like, my background's mostly in software, so I try to think about things like how you build software. And so you first have to get ancient DNA, right? And so there's kind of three fundamental parts, right? There's ancient DNA, there's the closest living relatives, and then there's the tools to make it possible. So
how old is the oldest ancient DNA? Because I'm going to ask you, because everybody asks you, it's your number one question, can you bring back dinosaurs? Is there any dinosaur DNA out there?
There is no dinosaur DNA. George and I both agree philosophically that you should not ever say things are impossible, because maybe we don't fully understand it yet. I think we're learning things every day, which is also not a very academic mindset I might have you. Most academics think we know everything. So I deal with that quite a bit. But I think I know nothing, so I'm on the other side of the spectrum. But right now, you can go back a little over a million years. Our oldest, we have about 59 mammoth genomes that we're working with, and our oldest is a steppe mammoth. Which I would argue is still a woolly mammoth, but a steppe mammoth is currently classified, and it's 1.2 million years old.
Awesome.
But most of the DNA we work with is, depending on the project, hundreds to thousands of years old, in that kind of range, which is still a long time.
DNA degrades very rapidly.
Very, very rapidly, right? The minute you get blood out of a system, it starts to degrade, right? And so what we do is you first have to find ancient DNA, and you've got to, a lot of times there's this thing called coverage, right? Because these big DNA reading machines, they aren't 100. They've gotten incredible, but they're not 100% accurate. So the more coverage you can get, meaning the more times of the full genome that you can read, the higher likelihood that they know it, at 3081 that's a C, right, versus a G, right? And so it's giving almost like a probabilistic score for each letter at each space and at
each position, right?
Yeah, at each position. So the more coverage you can get. So if you only have like 1x, meaning that this is a destructive sampling process, meaning you put it in, it's like when that old claw game, you put it in, and if you don't get the teddy bear, you still lost your money, right? And so you put the DNA you do this library prep, but it destroys the library in the sequencing process, right? So therefore, you've got to get enough DNA. And the problem with ancient DNA is, to your point, Peter, it degrades very quickly. Cold, dry places are the best places we get DNA, but it degrades very quickly because of heat, acidification. That's why I love Brad Tarpitz is terrible for this. And also, you have animals that die on top of animals. You have animals that eat animals, defecate on animals. You got bacteria. So you have to then screen it and make sure you understand what's truly endogenous, like what is actually that animal, right? And that's literally kind of a numbers game, right? So sometimes you get zero DNA on species. Sometimes you get a lot of endogenous DNA.
So mosquitoes trapped in amber just isn't the thing.
It's just, so not that we've tried. But amber is not a great storage vehicle. It's very porous. It's not a great storage vehicle for DNA. So there is no DNA for that. And I don't think that we'll get back to, I don't want to ever say impossible, because who knows. But I people still think Loch Ness Monster is there. So if some crazy lineage of dinosaur magically existed somewhere and died during the Ice Age, then that would have been great. But I don't know if that I don't think that most likely did not happen. So you can go back about 1 million years. So then you get these pieces of DNA, you do the sequencing, and we got about a 13x. So we had a full read of the genome 13 different times. And you can do what we do probably at 5 to 6x, but you really, if you get north of 10 or especially north of 20, then for what we do, which is called functional de-extinction, because we're not trying to clone these extinct species. There's no living cells. You can't clone from a dead cell, from bone. You can't clone from a dead bone. we're trying to identify and read the genome and then use synthetic biology to engineer in those lost genes to time. And so once you read it, you compare it to the closest living relative, because why would, it's like, if you're going to make a dire wolf, you shouldn't start with a frog, because there's hundreds of millions of you. That's a lot of changes, right? And so dire wolves, for example, are 99.5% the same as gray wolves. And many people didn't know this until we just submitted this paper, which is currently the #1 paper on bioarchives. We actually crashed bioarchives on. So two other weird things. We crashed bioarchives on Thursday when we uploaded. Bioarchives went down. It was the #1 research paper. I think it still is right now, and it's on a preprint server. Oh, and also Reddit shut down Colossal for a week. They said, they literally put out a statement. I don't know if this has happened before. There was a statement last night that said, any mention of Colossal Biosciences, dire wolves, any memes will be banned for 1 week. It's the craziest thing. It's the dumbest thing I've ever seen. So anyway, back to the science. So once you have, and there's no like GCP of species, which I think there needs to be. We're actually advocating the federal government to do this. There's no like biobank or biovault, like the equivalent of the seed vault, that has all these cells for wolves that are immortalized, or pluripotent stem cells. No one's done genome sequencing on all of this. No one's done any of that. So then we have to go do all that, and then you compare the two. And then once you identify those genes, we look for areas in coding regions and in regulatory regions, in areas that we know will drive, or we at least believe will drive certain types of phenotypes. And then we engineer them into the genetic donor. In this case, it's the closest living relative being the gray wolf. And then we identify those, we edit those into the gray wolf. And then we do a process called somatic cell nuclear transfer, which is basically cloning, which Dolly made famous. Only we now use like robotics and lasers and all kinds of stuff to make it much more efficient. You put it into a host, and if everything goes well, you get a healthy animal.
Ben, what percentage of your team and your tech do you consider software versus biology? How much is this is a biology company? How much is
I'd say it's half and half. And so, we spend a lot, like the sequencing, once again, this goes back to education. Some people were critical where they're like, but they didn't use tiny tweezers to move the DNA over here. But they don't understand synthetic biology. And so it's like, so this is awesome. People were like, were you frustrated? I got an interview over the weekend, like, were you frustrated by that comment? I was like, no, this is an educational opportunity, right? No, like, this is cool. Like, you think that you move the DNA from here over here. That's not how it works. We just read it. You've said this before, Peter. It's just a different coding language. And so we read the code, and then we rewrite the code, and we either change this code or we synthesize a block of code and stick it in. We don't move it with tiny tweezers.
How much of this is done by using CRISPR?
CRISPR's become the catch-all for genome engineering, right? It's a combination. So one of the things that we've done really well is there's knockouts, there's knock-ins. I mean, you can knock stuff out of the genome, you can knock stuff in the genome, you can change individual letters. We do a lot of changing individual letters. And some people trivialize that, which I think is insane. I'll give you an example. This is a conservation example that's amazing. And this goes directly to your question. So in one of our tools of just being able to change the individual letters, right? Not doing a full knockout, but changing this from like a C to a G. We have a project where in Australia, they've actually introduced cane toads from South America. What's killing all of the marsupials, specifically the northern quoll, they're critically endangered now because they're eating this cane toad that they did not evolve next to, and the neurotoxin kills them. Well, guess what we found out? When we studied snakes, obviously not mammals, and other small mammals that eat cane toads in South America, that they have a similar change at one nucleotide. So think of that 3.5 billion base pairs. One letter, one change confers a 5,000 times resistance to cane toad toxin. So we've now made Dunarts, which are the close living relative, before we wanted to work in the endangered species, we want to work in a little model species. We've made Dunarts, which are another carnivorous marsupial, that are now 5,000 times more resistance to cane toad toxins with one letter change. And so when people say, but that, making one letter change isn't that big a deal, I was like, one letter change could change the entire animal. You could literally, like George put out a statement, says you could make an entire new species with one letter change.
That's extraordinary.
Wow.
And so, and then to answer, and then we also do DNA synthesis. So if there's a lot of changes all at the same time, sometimes we'll synthesize that block and just put that whole block in, because it creates a lower probability of off-target effects, because you'll potentially only have off-targets at the ends versus like making 20 changes in a gene. So, and what Colossal is probably, I would argue we're the best at, is multiplexing, meaning that we take all those technologies, put it all in one big array and kind of one big guide and deliver it, and we're pretty good at that.
Huh.
How much easier is the next species to de-extinct? Because when I look at what you're doing, if I use the computing architecture as an analogy, you've got hardware, you've got BIOS, you've got operating system applications, right? And you're essentially reinventing that entire stack in different ways to cobble together what you're trying to do.
Right.
It's not like you're writing one little application that runs on a very standardized, well-understood stack.
Exactly.
You're reinventing the whole stack completely. Now that you've done it once, does the next time become exponentially easier and then much easier after that?
I think that the editing becomes exponentially easier and the delivery becomes exponentially easier. We're working on some things with on the embryology side around like, how do you have and we're not there yet, just to be clear. We've not done this. So I don't want to claim that we've done this. We are working on some pretty interesting ideas around a universal donor egg, where you can have matched mitochondria, because you can't go too insanely different. Like I can't use like a cow egg, which is a different size, to grow an elephant, even if the size worked the same, because you have the potential, let's say, for mitochondrial rejection. But if you can make a universal egg and you can match the mitochondria, then you have a universal egg that could work for any species, which is pretty interesting. And then you don't have to do the process of stem cell gametogenesis. So sometimes people are like, you guys haven't thought about embryology. I was like, that's all we think about. And so to your question, I think the editing, the comp bio is scaling quite well, right? Software and compute. The models that we're retraining on what works gives us a better idea of what tools to use for what job. So that's scaling really well. The multiplex ability and off-target in the monoclonal screening, so then screening all the cells, we do a lot of sequencing. We even do the reason why we know that our animals are healthy before we put them in is we screen the embryos. We do full genotype sequencing.
You have
on
to,
all
yeah.
of, which is insane. Like it's a lot of money and time that we do all of that. So the sequencing scaling, we're getting better at the library prep for ancient DNA. I think that the big thing is, I think that we will get to the point that we will be able to synthesize eventually full chromosomes, and I think we'll get to the point that I think it's a ways away, but I think we'll get there. And then I think we'll be like, we've already delivered in published literature. 35 kb or 30 kb, I think, is the biggest large cargo swap. We've already done 100.
KB is a kilobase, 1,000.
Kilobase.
Yeah.
So it's 1,000 letters. So we're gonna.
Ben, what? Yeah, go ahead. Sorry.
So I think that's all scaling. The two areas that I think will scale over time is, this goes back to your stack analogy, is like the BIOS is similar, right? But we have to create different, the editing and all the tools that you develop for the application layer, I think, get better and better and better. The two things that we are spending a lot of time on is that universal egg embryology side, to make that easier so it doesn't have to be a custom, chip architecture for every single species, right? The second thing is and kind of on the bio side, I think it's interesting to think about, or what we've been trying to think about is, how do we make it where what are the universal truths across certain genes or gene families or pathways, right? So like dogs scale really well. So if you have a Chihuahua and then you have a Great Dane, or you got a dire wolf, right? Dogs and wolves are dogs. They scale really well, right? They scale 1-to-1. Not all species scale really well. And so if you were to take like a goldfish and try to make it the size of a killer whale, it wouldn't scale like that. So there's only a couple of clades of animals that scale like that. And so how does that work? And how does that work like with El Coral and some of these gene families? And how is that then replicatable across mammals? And then separately, what are those functional equivalents in birds? So those are the things that we're trying to, that don't scale, as well as the media. So all these cells, kind of like a little bit different media, which
Media is the growth medium in which these cells are getting nutrients and growing. Yeah. So Ben, one of the things about taking on a moonshot like this is along the way towards this massive vision, you're solving all these other problems that can easily become spin-out companies. Right. And you've been doing that. You spun out Form Bio, which is fantastic. And one of the spin-outs I can't wait for you to talk about is the idea of artificial wombs. I mean, you just had a baby. You didn't use an artificial womb. You used your wife, which was great. We have surrogates we can go to, but this idea of an artificial womb, we've seen in science fiction for a while. How far off are we from full gestation artificial wombs?
It's a great question. So we have a 17-person team on it. Our goal with artificial wombs, because Colossal, to your point, doesn't work on anything human. Anytime that we have a technology that has an application to human, we patent it. We patent a lot of technologies. We actually patent some stuff recently around P53 in cancer. And whatnot. And so,
which, by the way, P53, one of the reasons that whales live so long is they've got extra copies of this P53 gene.
Yep. And so do elephants. And elephants, we breed, I mean, I guess we all breed the same thing with whales, but it's easier to study elephants than it is whales, right? Because they still go underwater. And so I think there's a lot of cool tech that can come from that. But on the artificial womb side, we spin everything out. So we won't ever make an artificial womb for humans, but I think that someone could potentially use our technology to do that. I will say it's harder to grow an elephant, not ethically, regulatory, or philosophically or religious. Like, it is harder biologically to grow some of the species we're working on than a human. And I think that if we continue on the current course and speed, by the end of 2026, we will have the world's first mammal birth fully ex utero, where we went from, it'll be small, it'll be an elephant, it'll be small, and then we'll scale from there. But our vision for that, once again, goes back to conservation, because imagine a world where you can grow, everyone knows about the northern white rhino, which we're the genetic rescue partner on. But imagine a world where you could grow 200 genetically diverse northern white rhinos in a lab. And then, without ever having to interfere with another animal or a rhino, and then that goes into those baby rhinos. Then get those work with rewilding partners to put them back into the field. So I think artificial wombs, if you can do multiple different placental types, will change conservation, and I think we could productionize endangered species development, and we could. I think we could save every species on the planet.
Well, let's pause on that moment. Save every species on the planet. That's pretty extraordinary.
When you said 2026, that's like next year.
No, I know.
It's right there. Okay.
Yeah. So
okay, I want to give you an umbrella comment, and then you tell me how close we are to this. Okay. One of the holy grails of synthetic biology, when we used to talk about this, was that if you get to that holy grail, you essentially are looking at DNA as a Microsoft Word document, which we can edit. And every one of our cells is governed by the DNA that tells it to be a liver cell or heart cell and how to operate, etc. If you get to that point, the human being of 50 trillion cells or whatever is essentially a software engineering problem. Right? How close are we to that point where you can edit it as easily as you can edit a Word document?
It is a focus and funding problem. It's not a lack of knowledge problem. And so, everyone's spending all this time on large language models, which is great. If the same effort goes into this, solving specifically this, I think it's 5 years. If it doesn't, I think it's 10.
Got it. Still. And by the way, AI is going to be the biggest accelerant to all of this.
Yeah. AI, access to compute, and then eventually quantum, those combined with synthetic biology. George has visions that are crazy about synthetic biology. We've talked about
So define synthetic biology, and let's talk about crazy.
Yeah, let's go crazy.
Okay, so it's the way there's lots of definitions for these things, but we look at synthetic biology as a way that we can use data and AI and other tools to basically change life, engineer life, or direct life in a specific way. So that's things like, making drought-resistant plants, making drought-resistant animals. There's a terrible process that animals go through for dehorning them, because the cows are now, like, everyone loves to think about cows in these beautiful fields like they see on Yellowstone, but they're really not for the most part. And so they dehorn them because a lot of times they're so close together, they'll stab each other and they'll get infections that causes disease and go to the herd. So they physically dehorn them. You can actually we could engineer them to just be hornless cows, right? So then, and I'm not encouraging eating meat. I'm just telling you that is something that exists today. And so synthetic biology affords us all these opportunities, right? We've got a company called Breaking that we started, which is about using using synthetic biology to supercharge this microbe that literally breaks the chemical bonds in plastics. It doesn't make microplastic, it doesn't eat plastic, it breaks, that's why I call it breaking. It breaks the chemical bonds in plastics, right? And so it just makes biomass as an output. And so, I think that we will eventually get to the CAD software of biology. To Salim's point, is like, I think that we will be able to cure most disease states. I think that we will be able to do epigenetic cell resetting. I think we'll be able to live youthful lives for as long as we want outside of natural causes or outside of acts of God and some crazy thing happens to you. I think that George and I talk about living one with nature, and we have this vision because George and I both believe that we're going to live hundreds of years. And so we think that there's, and so one of the things that we think that's pretty interesting is if we can grow, instead of a tree grows and you chop it down, right, and you make a house, why don't we make trees that why don't we make trees that this is literally George and I's crazy, people are going to think, oh, these guys do mushrooms, but we have this idea of what if we could engineer trees to grow faster and grow in the shape of a house? And what if you could use trees as water filtration? And what if you could have bioluminescent fungi in there, right? And what if you could literally engineer and tell a tree to grow in the form of a house? Right. I don't, that sounds psychotic, but I don't think that's in the next 5 years, but I think that's in the next 100. I don't think it's that. I think it's closer than people think.
I mean, we as humans and all animals are effectively molecular robots, right? We're designed on a molecular basis and we function in different ways. And one could imagine, putting ethics and morals aside, that, and I use this always as an example at Singularity University for synthetic biology. I said, I'm going to engineer something that looks like a cat, except it walks around your carpet and it eats lint and it pees stain remover. And that's its purpose. And it just goes around and cleans the house.
Yeah.
But you can imagine that. I'm not going to get into the alien conversation, but if I were a future civilization, I would engineer sort of aliens to pilot the spaceships, and instead of robotic systems, you want systems that are self-healing. It was about 13 years ago. I had my two boys, and I remember at that moment in time, I made a decision to double down on my health. Without question, I wanted to see their kids, their grandkids, and really, during this extraordinary time where the space frontier and AI and crypto is all exploding, it was the most exciting time ever to be alive. And I made a decision to double down on my health. And I've done that in 3 key areas. The first is going every year for a Fountain upload. Fountain is one of the most advanced diagnostics and therapeutics companies. I go there, upload myself, digitize myself, about 200 gigabytes of data that the AI system is able to look at to catch disease at inception. Look for any cardiovascular, any cancer, any neurodegenerative disease, any metabolic disease. These things are all going on all the time, and you can prevent them if you can find them at inception. So super important. So Fountain is one of my keys. I make that available to the CEOs of all my companies, my family members, because health is the new wealth. But beyond that, we are a collection of 40 trillion human cells and about another 100 trillion bacterial cells, fungi, viri. And we, don't understand how that impacts us. And so I use a company and a product called Viome. And Viome has a technology called metatranscriptomics. It was actually developed in New Mexico, the same place where the nuclear bomb was developed, as a biodefense weapon. And their technology is able to help you understand what's going on in your body, to understand which bacteria are producing which proteins. And as a consequence of that, what foods are your superfoods that are best for you to eat? Or what foods should you avoid, right? What's going on in your oral microbiome? So I use their testing to understand my foods, understand my medicines, understand my supplements. And Viome really helps me understand from a biological and data standpoint, what's best for me. And then finally, feeling good, being intelligent, moving well is critical, but looking good. When you look yourself in the mirror, saying, I feel great about life is so important, right? And so a product I use every day, twice a day, is called OneSkin, developed by 4 incredible PhD women that found this 10 amino acid peptide that's able to zap senile cells in your skin and really help you stay youthful in your look and appearance. So for me, these are 3 technologies I love and I use all the time. I'll have my team link to those in the show notes down below. Please check them out. Anyway, I hope you enjoyed that. Now back to the episode.
What are some of the crazy conversations you have with George when you're dreaming up without any limits? Let's hear some of that.
Well, I think the treehouse one is pretty crazy and
pretty
weird.
Good there.
Yeah. Another one that we've talked about that I think could be pretty interesting is how do we engineer in you've seen these. You've probably heard about phages, right? And these microbes that you can get in the dirt. Every time they take a scoop of dirt, they find new bacteria and stuff that doesn't exist, right?
So phages are viruses that infect bacteria versus viruses that infect humans. And the numbers are, I think there's a billion, quadrillion phages on the planet. There are more phages on the planet than there are stars in the universe.
Yeah, it's crazy. It's the most insane. Every time you scoop a thing of dirt, they discover literally you just go outside.
Just
and
Google.
Everyone can make a discovery. Just
Google
go grab
the number of phages on Earth. You'll be blown away.
It's crazy. But they've been using these lattice architectures to actually. Then they've shown that in a typical scuba tube. And this isn't with synthetic biology, not even tainting synthetic biology. With just a scuba tank, they can 3 or 4x the volume of oxygen that it can hold using this kind of structure from some of these phages. And I think it's really interesting. And so I think so some of the stuff that we've George and I have also talked about is how do we build self-healing outside of humans and outside of houses, but how do we build underwater cities that are also self-healing, right? And so that's probably our biggest and craziest dream is how do we, if you look at the world's, what's interesting about space is it makes you think about closed systems. What's interesting about underwater is that it makes you think about closed systems, but you have a more of a stable temperature. You don't have this negative 500 to 500 degree or 500 or 250 to 250, 500 degree variant in the sun that's instantaneous. You don't have the vacuum, you don't have the radiation. It's also the cost per kilogram of sinking something is much cheaper than putting it up in space. And so we've talked a lot. One of the more weirder ideas out there was we've talked a lot about if you just look at the surface of the Earth, we could do a lot of cool things, and it would force you to build, very sustainably cities underwater. And so that's a project that we're interested in. That may be a 2090 project, but I think we'll get there.
All right, I got to ask you this question, and I'm gonna force some version of an answer. So a royal or a decabillionaire comes to you and says, Ben, I know you say it's impossible, but I want to create a dinosaur. How do you do it? Now, I'm not saying you are doing it, not saying you plan to do it, but sort of theoretically.
Yeah, so there is no dino DNA, right? And so just to kind of give a shout out to the haters, Jurassic Park is not a movie about dinosaurs; it's a movie about genetically modified birds with dinosaur and frog alleles, or it's a movie about dinosaurs, depending on how you want to classify our direwolves. So there is no dino DNA. If I were to try to go build a, I don't think today you can. I don't think that you could bring back a dinosaur. I think using synthetic biology, and probably not today, but probably 10 years from now, 8 years from now, some period in time, you could do an ancestral state reconstruction of what we know of the tree, and I think that of the phylogenetic tree, and I think that you could do a giant sequencing project and I think there's enough that is conserved across multiple clades of birds and reptiles that you would probably be able to go down to make like an archosaur, which is probably at the very base of the tree. It's like the basal animal before it kind of stuff starts to get weird and split. I think that you could do that, and then you would be engineering for phenotypes, right? So I think you'd be looking at, looking to drive certain phenotypes. And I think a lot of those, at least we understand computationally at this point what those protein coding regions are. So I don't even know if it'd be less of a dinosaur than a dinosaur existed. And so that's probably where I would start. But I think it's a huge project. I think it's a lot of money. I don't think it's a $100 million project. I think it's quite a lot more larger.
Is there any possibility that we can harvest DNA of a dinosaur and find that it is preserved in some place, some way, somehow?
The problem is DNA degradation and fossilization. And you have to remember, when the dinosaurs perished, it was due to extreme heat. And so,
right.
There is dinosaur DNA in the form of birds, right? Birds exist and they're dinosaurs. Mm-hmm. And so, but I do think that I don't think you'll ever get to the point that you will have true dinosaur DNA. There's people like Dr. Kenneth Lacavara, who's arguably the number one paleontologist in the world, who discovered the 4 biggest dinosaurs, including Diamandis, which is the biggest dinosaur. He called me last week when everyone was debating all this stuff. Well, not debating all this stuff; they were only debating the name. And he said he had the same problem with Diamandis. He said that it was the biggest dinosaur, and he did it based on kilograms and all this stuff. And a lot of dinosaurs, they find like a bone, and they're like, it looked like this. But this one, it was you can Google, and I don't know what percent, but it was like 40 or 60. It's very, very complete for a large dinosaur. And he found it in Argentina. It's a super cool story. And he had people that called him, and he said it was so annoying because they wanted to argue not like U.S. versus metric system, but they wanted to come up with a measure with a dinosaur mass unit. And so he got into this big debate when it came one of the biggest dinosaur discoveries ever, and it was and a large part of it was because I think he said it was like 60 tons or something like that, and people wanted to debate a metric that everyone could agree on of dinosaur mass, which is ludicrously absurd, right? Yeah. But Kenneth, one of the things he's done that's pretty cool is he's demineralized dinosaur bones, where we can get those amino acids. And what his long-term goal is, it'd be cool if you could pick up a dinosaur bone. And this is his work, not ours. We are not doing this. So I just want to make sure I give him full credit. It'd be cool if you could pick up a dinosaur bone and be like, and you found it in Montana or North Dakota. So you could say, is this a T-Rex bone? Is this a Triceratops? And let's say that you didn't have like the dating of the geological formations around it. You could demineralize a piece of the bone, and based on the amino acids, say, oh, this is a Triceratops bone. Which is kind of cool. So, but those are like you can't glean any data on how to build the animal out of that.
So listen, I remember at the very beginning, we're talking about your vision. It started with the woolly mammoth. It sort of went off into thylacine and discussions about the dodo bird, about the dire wolf. And so how many different species have you had conversations about bringing back? Rough order of magnitude. Because you must be getting calls from all different parts of the world.
20, 25.
Yeah. What's your roadmap here, pal?
So we're working on the mammoth, we're working on the Tasmanian tiger, we're working on the dodo. Given our most recent round of funding, we will most likely expand those into other avian and non-avian species. We have not quite cracked the code on the primordial germ cells, so it's a little bit different in birds and mammals. This goes back, Salem, to that media question, right? It's like getting the media that PGCs want to grow in for birds is pretty hard. And once we do that, once we show we can do it for pigeon, which has never been done before because dodos were pigeons, just like dire wolves were wolves. Once we do that, then I'd probably feel confident in adding another avian species. But there's amazing species out there. And there's some we can't do until we get further in the tech. Like my favorite animal is, you should look this up. It's the stellar sea cow. It's the coolest damn animal ever. So I don't know anyone in the world that doesn't like manatees. Like manatees are just awesome, right? They're harmless. They're cute. They're vegetarians. They're kind of tubby. They move kind of slow. They do great stuff for the ecosystem. There's not like Facebook hate groups for manatee, right? If they are, those people should go straight to jail.
Or El Salvador.
Or I apparently we do that too now. And so there was this thing called the stellar sea cow, and I'm probably going to butcher the years, so someone will yell at me online about it. But it was like it went extinct like 60 years or 30 years after it was discovered, and it was all upon the Pacific Northwest. And apparently, the kelp forests there were even thicker because it would eat and defecate, and they are whale-sized, like they're literally like bigger than whales. Manatees.
Wow.
And they were apparently really docile, and they would just like swim up to people, and they're curious, like I guess like bottlenose dolphins are, and people would just spear them and kill them. And so
curiosity is a bad evolutionary trait for
large, slow-moving megafauna for sure. We've seen the rise of we've seen like the rise of early human on continents and the decline of megafauna be inversely related, nearly 1-to-1. Once humans move to a certain scale on a continent or subcontinent, the megafauna drops at a very predictable rate.
Yeah, we just like
which kind of makes sense, right? We go after big, we all work together, kill a couple of big things. A lot of times the big things have single bursts, long gestations. You don't have to kill all of them to send them down on a decline. But I would love to do the stellar sea cow, and I will say publicly, I've said 100 times, but no one listens to me. It's 100% on the list. We just can't grow it in anything. So I got to get artificial wombs to work, and we got to get it to work for elephants, and then eventually we could do stellar sea cow. I would love to do stellar sea cow.
Amazing.
What is the business model that gets your valuation to where it is? Is it spinning off breakthrough medical ideas? I would say originally, and this is what's been cool, like one of the things I think we're good at is we're also good at saying what we don't know. And the original pitch deck, which Peter saw, which was moderately shitty, was, hey, George Church says he can bring back a mammoth. We're pretty sure that we make money somewhere in there, but we don't know, right? That was kind of the pitch deck. And so here's how it's evolved. And here's kind of the three ways that it's evolved. It then became tech, which is working, right? We've spun out 2 companies publicly, Form Bio and Breaking. We spun out a third one that we can't talk about yet, but I'm super excited about. Its valuation is already over $100 million in the seed. I think it's super cool.
I don't think it'll have any philosophical debates on what to call it.
It is very
so
cool.
it's cool. It's like it is what it is. So I'm super stoked about that one. We have another one in embryology that we're really excited about that we're working on. That we gotta go a little further on, but I think could be helpful to IVF clinics. So there's technology which you get. There is a long-term, and this is not really a science thing. This is more of working with governments and working with auditors, ecologists, and whatnot. But you've probably heard about carbon credits. There's now a new thing called biodiversity credits. It's getting a lot of traction because some of the problems with carbon credits is not that they're manipulatable, but they're sort of manipulatable on some level. But certain things like biodiversity credits aren't, right? Like if you can understand and quantify the value that a forest elephant brings to Gabon. Like that's now a thing. Like it's like research by people like PwC. It's certified by Lloyd's of London, and so there now is becoming a biodiversity economy where, and part of that is really helpful because if you can put the value of an animal, right? This is the old hunting adage, right? Where people are like, well, if we kill a lion for $100,000, it's a good thing because we're saying that lions are worth $100,000, so don't poach them. I'm not a hunter. I've never killed anything intentionally, probably a goldfish, but like that wasn't intentional. But it's like, I wouldn't, like I as not a hunter, I at least can step back and understand what they're trying to say there on some level, even though I think that's partly manipulated so that they can achieve what they want to achieve. What I'll tell you though, is that I do think that if you do put things of value, people tend to protect. And so if you can protect an animal and it has a certain value that you can trade against, it becomes some sort of a commodity play. And what we're seeing is with this Paris Agreement that 62% of the pledges pledged nature-based solutions, rewilding, restoring ecosystems, restoring bogs, all these types of things, right, and wetlands. And animals are critical to all of that. And so where we think that market's going is a combination of biodiversity credits, nature and carbon credits into what will probably end up being called nature credits. That's highly quantifiable. And the variant trade on it will probably be based on sexy factor, right? Like you have a lot of these companies that cannot become carbon negative because they're in the mining business, they're in the oil extraction, they're in the extraction economy, right? And we still live on some level, we still live in the world where there's not unlimited, solar, or there's unlimited solar, but there's not unlimited, cold fusion and stuff like that yet, right? And so, like, until that happens, we still have and there'll still be a transitional period where you have an extraction economy. Well, if you put a value on nature, then you can create annuities based on that. And so we're working on models around rewilding that turns the animals into annuities. And so if we can show that we can make these animals with this genetic diversity, think about an annuity that's not only growing and is highly valued because of a company like Chevron or Sumitomo or Exxon or whoever would buy those credits because they have to be from a compliance perspective or kind of an ESG and their kind of social good perspective. They are also annuities that multiply because they have more babies. They cause more of a garden. So there's the second thing that we are now pretty deep in, right? And so the science has to work to do that, which is proving to be on the right track. And then the third thing that's interesting is while we open source, we didn't know this. And I talked to Peter about this offline like 6 months ago, but we open source all of our technologies for conservation. So anybody can use our technologies for conservation. We also started a foundation with $50 million to go fund conservation projects, right? They're innovative.
By the way, congratulations on that. And people need to hear
That's huge.
that. Right?
Yeah, nobody talks
that's
about that.
amazing.
It's like, but it's not a dire wolf. Yeah. What embargo? And so those are my life. But yeah, the foundation's great, and we're working right now to get another big donation that once again aren't coming from conservation. They're coming from tech people that we're trying to bring tech into conservation. So this is new money to conservation. But what we're finding is I think you'll love this, Salim, because it goes directly to open source software. If you build open source software, you build a community, people start to use it, devs start to use it, but then you have someone like the Red Hat, Microsoft type opportunity where it's like, okay, we want to go implement this at scale for Cisco. We don't want our developers to do that. We love that you have all this documentation. You guys made this code. We want you to do it, right? And so while we open source all this for governments and NGOs and everyone else, we are now having governments saying, in our hands, we think we can get this done. But in your hands, we'll pay you. And there's one government that's trying to get a recovery of a species. It's going to cost them about $300 million to get to that species, and it's going to take 23 years.
Wow.
We can do it in less than 3, and we can do it for like $70 million. And so it's not just the $300 million. It's like that could go to more recovery efforts or education or water or whatever. It's the fact that we can recover a species in less than 2 decades. And so we're starting to see these government opportunities like biovaults and other things where it's like, this is work, right? So it's not free. It'd be easy if it was all just free, but we're now saying, how do we build a consortium of partners around the world where we can also biobank all species, but not just put them in a freezer. There's like, how do we build pluripotent stem cells? How do we do immortalized cell lines? How do we do sequencing? Well, all of that's compute money, right? Someone's got to pay for that. So I think that we can offer this redundancy model as well as kind of this acceleration if people want it. But once again, we're happy to have people just use all of our stuff for free if that's
Ben, when am I going to go to LA Zoo and see a colossal dire wolf or a woolly mammoth? I mean, that has to be a important future business line where it's scientific education, right? I mean, you'd have lines winding around any of these facilities.
It's a really great question, and we get it a lot. And in the early days, we had a lot of folks from that community want to what do we have to do to sign up first, both nationally and internationally. But as we've spent a lot of time thinking about it, I think it's more likely that you will see them in a ecological preserve being back in their natural habitat than you're going to see them in Los Angeles. So you do have to travel, unfortunately. You have to travel to their locations. But I also think that one of the things that we've started to have conversations with governments is the brand building that can do for the country. So we're talking to northern states of the United States, and we don't want to be exclusive. So or exclusionary. People argue the zoo thing to us all the time in a positive route. They're like, but if you made a zoo, what about kids that want to see this and get inspired by it? Because there's been all these studies that show that zoos actually are good for people care more about animals if they go to zoos as a kid. There's actual peer-reviewed science that shows that. Not all zoos are Tiger King. There's great zoos like the San Diego Zoo that do great stuff. Groups like the AZA and others are trying to do more for conservation. So you've got that, right? You've got that, and we're seeing that works. What I would tell you though is, our focus is on rewilding back into the ecosystem. And so the two things that we've talked about, and I don't know where we'll end up on it, is we've said to Tasmania, you should once we have enough thylacines and once they're back in genetically diverse enough to be reintroduced, we've gone through a very thoughtful feasibility study of rewilding them. They're benefiting the ecosystem. You should offer ecotourism to see them back there, right? And then, not there's this thing that I didn't even know existed, but there's a sloth cam and there's a bald eagle cam and there's all these cams. But it's if you can't, we don't want to be exclusionary. So if you can't afford to go to Tasmania, which is really not the easiest place to get to, I go several times a year. How do we bring that experience to you without making it about exhibition of the animals? And so we've been talking a lot about this. We've actually been talking to a lot of education partners, including the Australian government, about how do we do content, right? Which I know isn't the same, Peter, as seeing a mammoth in real life. But so we don't have an answer I think the short answer is we'll put animals back into the wild with collaborations with indigenous people groups and private landowners and governments for the purpose of ecosystem restoration. And then how do we put the science on display? Because the animals are awesome, but how do we bring the science on display, right? Because that is something that Jurassic Park nailed, regardless of whether how you feel about Jurassic Park, the movie. A lot of people know about genetics because of Jurassic Park. And that, who cares about the Rotten Tomato score? That did something. Like, there are geneticists today that don't want to make dinosaurs, but went into genetics because that movie got them excited about genetics. And so we're filming a docuseries. We'd like to build more educational content.
What I hear, Ben, is you've got an incredible respect for the life that you're bringing back, and it's not your goal to commercialize it in a crass fashion.
Right. And so I would rather us put animals back on ecological preserves, protect them. We don't even know, but very few people know where the actual wolves are. But we'd rather get them back in the wild, doing their thing in the wild. Maybe there's ecotourism like Kruger National Park, where money goes back to help the environment, help the indigenous people, help the local communities. Maybe we do something like that in collaboration with governments. But then, but to your question, how do we also, it is awesome science. So we're trying to film everything. How do we put science on display, not animals on display? And we don't have an answer yet.
I have a fun question. You and I have a common friend who's another extraordinary moonshot entrepreneur by the name of Palmer Luckey.
Yeah, Palmer's great.
Yeah, Palmer's amazing. I'll be doing a follow-up podcast with him in a couple of weeks. And when I get together with him, I brainstorm, okay, what would be a great X Prize? What should we be doing? Because he's one of the teams competing in our Wildfire Prize. Right? In fact, he was the very first person to register to compete in the X Prize Wildfire, and he's got a crazy solution, which I love. But we brainstormed, and so one of the prize ideas that we kicked around over dinner was the idea of an uplift prize. Can we uplift a species? Can we take a dog and make it far more intelligent, or shall we say Planet of the Apes? Introduce the genes that increase intelligence to these animals. Is that something that's putting aside the moral ethical?
It's a very Palmer Luckey.
Yes,
point.
It is. 100%.
Yeah, it's about as Palmer Luckey as it gets, right? And sometimes Palmer gets a mixed rap, but he is so brilliant. He is so passionate about the safety of America. And I've seen the people attack him online, and it's like, I want people like Palmer that wake up every day, that are that smart, and that are like working on a defensive weapon system or an offensive weapon system that is a deterrent for some bad guy not to hurt my kid. And so
you want him on your side.
Yeah, you want him on your side. We are lucky to have Palmer. I'm a huge, obviously he's a friend, full disclosure, and I think very highly of him. But sometimes he gets this polarizing thing because it's like, it's cute to, go to the grocery store and drive your car or Tesla or whatever and think that all is free. And it's just not. And you've got to have our incredible armed forces and people supplying them like Palmer to make our way of life possible so that we can do this. And we can do, it's wonderful that we can debate whether we can call it a dire wolf or not versus someone killing us for that, right? And that's fucking amazing. And so anyway, back to your question. I think that there are genes associated with that could be associated with intelligence. There's been studies been done in mice. I think that you can do non-invasive sequencing of really smart animals. Colossal is never going to work outside of humans. We also drew the line at non-human primates because we get the Neanderthal question all the time. And so we just said, great, sorry. And then people get sad. They're like, but what about Gigantopithecus? And I'm like, there's not really any DNA anyway. So no, we're not making giant apes. That's not what we are trying to do at this company.
King Kong is coming back.
Yeah, King Kong, not here though. And so I would say that for us, I do think that if you could make smarter animals like dogs or cats or something that you had that type of relationship with, I think that's interesting. But you also have to be careful, right? Because I think it's a very important ethical thing to really think through, because it's a slippery slope. Because then what happens when you make smarter, livestock, right? Then it's even worse for livestock, right? And so it's hard. I mean, it's hard balancing some of the ethical questions in the name of progress of synthetic biology, also. And so that's what, so we've, I know it sounds like a cop out, but that's why we've drawn some of these lines saying, hey, we're just not gonna do this, we're not gonna do that, because even though I'm not philosophically against some of those things, we will never work in some of those categories.
How do you deal with the invasive species problem? Like, for example, the Scottish went into New Zealand and took the gorse bush with them, figuring that would make good fencing, and that took over the island and totally messed up the ecosystem.
So an area I love is gene drives. Like nobody, and what's crazy is like certain people like the U.S. hasn't been as pro gene drives as I think they should be, but island nations like New Zealand and Australia are like, okay, we're in trouble with invasive species. We have to have new things. And I love gene drives because cats, for example,
define the gene drive for folks.
So gene drives are technologies that you can develop where you can introduce into a population where it will silence or change certain genes within that organism, and you can deliver it by food or other things. And so right now, Australia is like the face of mammalian extinction, and it's because of cats. They've introduced, like, everyone's cats. Cats love to have baby kittens, and the people let their feral cats get out. They get feral, and then they're killing and decimating these small marsupials. Well, there's people now that kill cats in Australia, right? In America, like, you'd go to, like, God knows what would happen if you shot a cat in America. But it's like, to Australia, if it's not their personal house cat, they hate them. They despise cats because it's killing their most unique. They have these unique animals that no one else has in the world, right? And so a way to handle that in a very thoughtful way that is healthy for the animals is you introduce gene drives where that cat eats it. Instead of it's not poison, it doesn't die. It has an offspring, so it does have another generation, but that offspring cannot give rise to more offspring. It's effectively sterile. So then after a few generations, there just are no more cats, but they get to live out their natural lives. They just don't get to over procreate, right?
This got a lot of attention back about 5-6 years ago when gene drives were being put forward to basically decimate mosquito populations.
And everyone, and I think the biggest concern is, everyone's seen one too many movies, right? And so, like, you got Resident Evil, and then people are like, oh, you make a gene drive, and then it turns us all into zombies, right? It just doesn't work like that. And so, but I do think that, or like one of the Mission Impossibles, I think they had targeted like a bioweapon around that stuff. And so you have to be thoughtful about this, but I do think that you can silence certain, you can silence certain procreation in animals using gene drives, especially where it's invasive. And I mean, we're doing kind of the opposite of a gene drive with these marsupials, right?
That's right.
If we make supercoals, then we don't have to engineer all of the other marsupials to eat coals, because to eat the cane toads. The coals love eating the cane toads. So then they eat the cane toads. So then they don't die. So their numbers rebound and they recover. But at the same time, there's other marsupials that don't eat those cane toads. So then they don't die because there's less cane toads. So people think this is playing God. People think this is geoengineering, but I mean, we introduced the cane toads, and we cut down the forest.
We're geoengineering by default anyway. So
every day, and so we should start being thoughtful on this.
I love the arguments that GMO is bad for you. It's like, oh my God, that's all we've ever done is genetically modified everything.
We've just been shitty at it.
By selective
I use the analogy.
We've been slow and shitty and unpredictable about it.
Yeah.
I use the analogy of film photography to digital photography. We've been doing breeding for thousands of years and nobody says anything. Now we've got the digital photography. We can do it at scale. And everybody's like, oh my God, we've been doing it forever.
Look at a pug.
Yeah.
Look at any of the species.
Someone thought we should breed a bunch of stuff together that ends with a pug.
Yeah.
Oh my God. Ben, quantum sciences, quantum computation, quantum tech, how much do you think about that as the next layer?
Yeah, where does that fit in?
Still way too early for you?
I think it will be a game changer for specifically simulation design for editing, and if you feed enough data into the model on top of quantum, you could get I think pretty good at predicting not just genotype to phenotype relationships, but you could get pretty good at understanding, what negative effects would be from editing. And so, in predictions of editing, like, hey, here's the 50 spots you should go edit. We always say the better we are at computation, and this annoys people, but it's true. Every edit has a risk. Every edit has a risk. It just has a risk. And to the question you asked earlier about when do we know everything about the genome, I think for humans it's that, but for all life, who knows, right? It's going to take quantum, it's going to take AI before we can truly understand it for all life. And I think that I think what's interesting about quantum is if you could simulate these things and simulate those edits, we always say the less edits we can make that get the desired outcomes and the lost phenotypes, that's the safest for the animal. And so that, like, if it takes 1,000 edits to make 1,000 edits, but if you can do it in 3, do it in 3, right? It's we have a very programming. This won't come as a surprise to you, but we think about this like programming, right? It's like if you could do something in 3 lines of code versus 1,000 lines of code, you should do it in 3 lines of code. So I think quantum will be a game changer. I don't like I meet with I see Will every year from MIT. He's great, and it's just like, but it's like I never know. Like quantum sensing is here. But quantum sensors are here, but it's like, and like quantum comms is kind of here-ish, but it's like, I don't know when we're really going to get there. I thought Microsoft's breakthrough late last year on some of their chip architecture is really interesting. But, when is it going to be truly here? Still, to me, is a question mark. It's 2 years every 2 years, at least in my experience.
You employ ethicists in the company, don't you?
Yeah.
What are they debating right now?
Well, we every single species we bring on, we go through a pretty rigorous process and include obviously them in that. Right now we're talking to them about one of the biggest things we're talking to them about is the current conservation. We're opening sourcing these technologies for conservation. We're making red wolves. Working on these projects, but then you get it's kind of our ethicists right now are focused mostly on how do we recognize I think that conservation is a bipartisan issue, and by the way, we hear that from the government, we don't just believe that. It's like both sides of the aisle. Like, go look at who retweeted us, right? It's like you've got Biden's #1 advisor and you've got Elon. Like you kind of have both sides of the aisle, right? In as far as the political spectrum, and we think that these are really important technologies and conservation are important. Right now, the bioethicists are helping us think through how do we educate the existing people on and how do we bridge, how do we show these technologies off from an ethics perspective, but also be able to rise above the politicizing of it on either side, not just one side. And so they're going kind of a step beyond even the bioethics side, thinking about how do we have these dialogues? Because, I was really sad that within a 24-hour period, we made a huge leap forward for conservation using these technologies by the federal government. But because it was by this government, it's seemingly bad. And, I don't philosophically agree with that. And so I think that we worked great with the last administration. We're working great with this administration. There's pros and cons to every administration. And so I think we just have to, I watch Bill Maher every week to probably show you where I lean on a lot of these things. And, Bill Maher's show last week was really telling, right? And if you haven't watched, I highly recommend people watching it.
Yeah, it was a great episode.
I think having a refusal to have a dialogue because one party or another party is super polarizing, you can acknowledge they're doing bad things, or you can acknowledge that you don't agree with them, but refusing to have a dialogue, that is as ignorant as things that you may accuse another administration of doing. So,
I think it's a testament. There's a testament here to your ethics and your MTP, where you're able to work with either side of that aisle because of the objectives, the open sourcing. I love the fact that you're open sourcing everything. It's such a huge thing for the world. It's really great to have somebody like you be at the forefront of something like this, because it could go so badly so many other ways. And you're navigating that very fine line of breaking through science, but doing it in a very, very thoughtful, ethical, even a spiritual kind of way. So I just want to hats off to you and all that.
No, it's really kind of you. Like, I got feedback, pretty negative feedback from someone I respect in the community, in the conservation community, because they said that I was empowering this administration. And I was like, there's a difference between empowering and educating. And if you don't educate people and you don't show up, I think it's always better. We showed up for the last administration. We're going to show up for this administration, and we're going to show up for the next administration, because like we said at the beginning of this, we are looking at conservation and de-extinction. We're looking at this on a 50-year horizon. And that goes beyond a 4-year party or an 8-year party. It goes way beyond that. And this to me is as big of as an existential threat as anything else.
My 13-year-old heard I was doing this, so he did a quick whip round in his class, and his class collectively asked the following question: what's the next species that we can look forward to?
I don't want to let your kids down. We are on target for the mammoth by end of 2028. We feel good about that. But the editing is moving really fast. We have done 300 edits in a Dunart cell. And so if the Dunart, and this is a bad non-answer, but if there's a 13.5 day gestation on the Thylacine, if editing progresses at the same exponential rate that it is, I think the Thylacine could beat the mammoth. And if we saw PGCs in Dodos because of the it's a pretty self-contained system being an egg. And you don't have to solve IVF or somatic cell nuclear transfer in a non-model species. Then the dodo could be. So I mean, right now it's kind of a 3-horse race, and it's unclear who's going to win. Not that it's a competition. We love all the species equally.
Gestation periods play into this, right? So what is the gestation period of an elephant?
22 months.
22 months. Wow. For any pregnant women out there, can you imagine 22 months carrying? Crazy. Mm-hmm. And the Thylacine is how long?
13.5 days. Yeah.
Talk about two ends of the extreme.
And the chickens, a chicken, which is what we use as a surrogate, we use these genetically modified chickens for the surrogates is 30 days for the dodo. Yeah.
So. Ben, Salim, you have a closing question, but I just want to say thank you for all the work that you're doing. I have said this over and over again, the difference that a individual can make in birthing a company is extraordinary. And I want all the entrepreneurs out there listening to understand that, right? You can have the idea, you can have access to technology, but if you've got a compelling CEO who builds a moonshot team, is driven by a clear, measurable vision and passion, you've attracted hundreds of millions of dollars at a $10 billion valuation, which is, I don't want to say it's insane, but it's massively impressive. And you're executing over and over again. So thank you. And in 4 years, I remember I have to say one thing. I remember in the earliest days, because when you started Colossal, the idea of a de-extinction company for the woolly mammoths had been around for some period of time, and people had been working on it, and it had been extremely slow in the nonprofit world, and people were upset that this moved into the for-profit world. But guess what? It's like hitting the acceleration button when you did that.
Well, that's that is one of the things that we often get is like, there's an article that came out a couple weeks ago that says you can't trust a for-profit. It's like, well, we are very honest that we are going to make a lot of money off the rewilding. Like I said that here. Like we think that we'll make billions of dollars on the animals being back in their natural habitats. We also think that we will make billions of dollars off of the tech that we're building. And so for us to be able to give that technology and subsidize, people don't realize this unless they've done technology development. They think of research and development as free. Well, it's typically a lot of research and very little that goes into development because a lot of this stuff just doesn't work. And
I love that there's a metaphor emerging in my head, which is you're not just incubating and bringing back old species. You're actually an incubator and a womb yourself for breakthrough technologies that change everything, that change humanity and change everything, which I think is awesome. It's very meta.
Yeah. And we're having fun, and I think we're making a difference, and so that's all we can do.
It's rare that I get to say I'm jealous about somebody's job, but I think you might have it.
It is a 365 7-day a week, but I always joke that I don't have friends or hobbies. So, I do have friends, but I work with all of them in some level, right? On some level. So I just, it's fun. I love what we do.
Amazing. Ben Lamm, CEO of Colossal Biosciences. Thank you, buddy, for your work. Please give my best to George. I'll be chatting with him shortly as well. Salim, as always, love having you in this conversation with me. And for everybody, so where do folks go to learn more about Colossal?
So we're just at Colossal on X, and they can go to colossal.com and find the rest of our social channels. And
when you go, if you listen to this podcast, go to your friends and say, "Did you hear about the miracle that occurred last week? It's extraordinary. 3 dire wolf pups that have been extinct off the face of the earth for 12,000 years are back again." And that is incredible.
They're also cute.
They're also cute.
Congrats on the baby, which is a real startup.
Yeah, it is a real startup. I'm learning that the hard way too. So
yeah.
All right.
Yeah, it's a self-learning startup. I have my own large language model continually growing. It's interesting.
You have to be looking at the birth and your son very differently, given the business that you're in.
Yeah, my son has no idea, obviously, what I do, and I think he'll really like it or not. I think it'll be a moderately binary outcome.
I just can't wait.
So Peter and I, neither of our 13-year-olds have any idea what we do either, so don't take it the wrong way.
He's pretty curious. Like at an early age, he's really weirdly curious, and so I think he'll dig it. We'll see.
We'll see what kind of pets he grows up with in his teenage years.
Awesome.
All right, take care, guys. If you enjoyed this episode, I'm going to be releasing all of the talks, all the keynotes from the Abundance Summit exclusively on exponentialmastery.com. You can get on-demand access there. Go to exponentialmastery.com.